Hey, this is Mike with Avio Consulting. If you're logging in for the webinar, welcome, glad you're here. We're gonna give folks about 1 to 3 minutes to join in, and then we'll get started. So thanks again for being here. It's 12:59. We'll give folks about 1 to 3 minutes to hop in, and then we'll get started. For those who have just jumped in, thanks for doing so. We're going to take about 1 to 3 minutes to let folks hop in, and then we will get started. Hello, hello. For those folks who have just jumped into the webinar, we're going to take about another 1 minute to let folks hop in, and then we're going to get started. So thanks for being here. All right, so for those of you who are here and welcome, with us, welcome. We are live, and so we're really excited to bring to you this webinar on Vault, Disaster Recovery and Performance Replication. We're really grateful for Saul for putting all this together for us. Would like to take a minute really quick and look at the agenda and the high level of what we're going to talk about today. First, Saul will start with an overview of the product itself. And then we'll jump into a discussion of high availability versus replication. Then Saul will talk a little bit about replication modes, and then jump straight into the demo itself, followed by Q&A. Want to point out a couple features of the Zoom call and the webinar. Down in the center, just to the right of the share screen button, there's a Q&A icon. You can click on that Q&A icon at any time and go ahead and put your questions in. You can also use the chat feature. We'll probably answer all those questions at the end or near the end of the talk, but go ahead and put those questions in as they come up so you can make sure and get those answered. I want to tell you just a little bit about the team that's bringing together this webinar today. Jordan Nichols is our marketing lead. He's behind the scenes making all this happen, so thank you very much, Jordan. I'm Mike Slack. I'm the Vice President for Sales and Marketing at Avio Consulting. And Saul Jaramillo is an architect here with Avio, and he focuses on our Hashi practice. 2 slides really quick about Avio overall. The company was founded in 2007 with a focus on modern application development consulting. We like to say as a company, we're more like the Navy SEALs than the Navy, because we have a very high and exacting standard of who is on our team, and you're gonna see that in the quality of what Saul presents for you today. We have a mentality that thinks to think big, but to start small and act fast so that we can deliver quick wins for our clients. That's really important for so many of our clients who maybe are at big enterprises where they see IT is seen as a bottleneck instead of being a source of breakthrough. And so we want to flip that script. Last thing I'll say is just a quick note on our product focus. Avio has 3 different key product areas that we work in. MuleSoft for API-led integration, Appian for low-code development, and then HashiCorp for our Vault, Terraform, Packer, and console work. With that, I'm going to turn it over to Saul. Thank you very much.
Thanks, Mike. So hello, everyone. Thanks for being here. My name is Saul, and I'll be conducting the next part of this webinar. And since we have a lot to cover, I'm just gonna jump right in. So a quick overview about Vault. Vault is HashiCorp's solution for securely storing and tightly controlling access to secrets such as tokens, passwords, certificates, and other sensitive data. Vault allows you to generate dynamic secrets on demand for systems such as SQL databases and AWS. So yeah, we can get dynamic credentials from AWS. It provides encryption of secrets at rest and in transit, provides a full audit trail of secret accessing, like who access what, when, right? It's capable of handling different types of authentication methods, such as GitHub login, username and password login, Active Directory, and many others. And of course, it allows us to replication, therefore providing consistency, scalability, and highly available disaster recovery. So as you might have heard me saying on the previous slide, I mentioned high availability and replication, but what's really the difference, right? High availability is a feature that has been out for a while now, and it's available in the open source version of Vault. In high availability mode, there are active and standby nodes, and if let's say the active node goes down, the standby node can take over the leadership and become the new active node. And this feature basically allows for the minimization of downtime. Also in this mode, all nodes talk to the same storage backend. And just to be clear, Vault supports multiple types of storage backends like Postgres, DynamoDB, and Consul, and many others. And since the enterprise preferred storage backend is Consul, that's what I'll be using for the demo later on. And talking about enterprise, replication is an enterprise-only feature. Replication uses primary and secondary clusters. And again, when I talk about Vault clusters, I mean a highly available unit of deployment that is made of one active Vault node and multiple standby Vault nodes. And since each cluster has its own backend, primary clusters and secondary clusters can have their own distinct backends. So one could have Postgres and the other one could have Consul, right? Keep in mind though that using replication does require a backend that supports transactional updates, such as Consul. So that's another reason for me using it in the demo. Basically, the most important thing to remember about replication is that data from primary clusters gets replicated to secondary clusters. So the first mode I want to talk about is performance replication mode. Performance replication is used to scale secrets and other configurations horizontally. For example, any access control policies, audit configurations, secret configurations, enabled authentication methods that you may have applied in the primary cluster, they will get replicated to secondary clusters. And that also means that things like retrieving static secrets and doing things like transit encryption can scale horizontally across multiple data centers. And the way that Vault scales horizontally is with a number of secondaries rather than vertically, as in the past, like increasing the RAM or the CPU. So in performance replication, write requests get forward back to the primary cluster, and because of this, performance mode basically scales reads rather than writes across data centers, and that's something to keep in mind. Another thing important to note here is that some items remain local to a cluster. For example, cluster-specific configuration, tokens and leases, or local mounts, those won't be replicated to secondaries. Also, when a secondary cluster is promoted to act as primary, applications must re-authenticate and obtain new leases from the newly promoted cluster. So for this reason, it's recommended to place a secondary cluster that is hosting secrets and services within the same data center, or as close as possible to the resources or applications that may be consuming them. So performance mode with mount filtering. And what does it allow us to do? It's basically the same performance replication that I just talked about. So you can scale your secrets horizontally, but it also allows us to add granularity to what gets replicated where, right? So we can either whitelist or blacklist which mounts are replicated to a secondary cluster per se. Also, filter mounts really help us comply with data movement and sovereignty regulations, such as for example, the Swiss Banking Secrecy Act. And if you're asking yourself right now, like, how could I benefit from this? Let me give you a quick example of for when you have like a very strict compliance or legal requirements or other types of fencing. Let's say we have two data centers, one with a primary cluster, let's say in Geneva, in Switzerland, where the banks are, the big banks, right? Let's call it data center one, and then one with a secondary cluster down here in Miami. Let's call it data center two. So in data center one in Geneva, we could set up a mount filtering rule to not allow any of the transit encryption keys, or as a matter of fact, not allow any other piece of data except for, let's say, custom policies to get replicated down to the data center 2 down here in Miami. Very cool, huh? So, and the third mode is called disaster recovery mode, and it's basically a mechanism that is designed to protect against catastrophic failures of entire clusters. So in the event of a disaster recovery scenario occurring, secondary disaster recovery clusters can be promoted to be primary clusters. Disaster recovery clusters fully restore every single piece of data, including local and cluster data. So yes, if you're thinking about that, disaster recovery does copy tokens and leases, unlike the performance replication, as I explained in the previous slides. Secondary disaster recovery clusters, secondary clusters that are in disaster recovery mode don't service any requests, read or write requests from clients, right? Until they get promoted to become the new primary cluster. And finally, disaster recovery replication can be used in conjunction with performance replication. Okay, all right. Demo time. So I'll be showing you a highly available multi-data center architecture. It's going to be distributed across 3 different geographical regions, Oregon, Ohio, and Frankfurt. The infrastructure as code was fully developed and deployed using Terraform, and the configuration management solution, which I used to tie all of the cluster setup together, I handled using Ansible. For those of you who never heard about Terraform or Ansible, Terraform is HashiCorp's solution for infrastructure as code. And it's a tool for basically building, changing, managing infrastructure in a safe and repeatable way. And Ansible is a configuration management and application deployment tool. Okay, so each one of the centers will be running its own highly available cluster. And for agility purposes, I just went ahead and ran the Terraform scripts a couple of minutes ago, and basically they bring us to a point that we have 3 standalone identical Vault clusters sitting in these 3 regions, Oregon, Ohio, and Frankfurt, and they'll have different purposes. The one in Oregon will be the primary cluster. The one in Frankfurt would be the performance cluster, and then the one in Ohio would be the disaster recovery cluster. At this point, I have solved one of the challenges that led me to do this this demo, which was the proper configuration of the AWS infrastructure to allow the three clusters to be able to talk to each other. And I solved that by configuring VPC peering among the three deployments, and also by opening the necessary security group ports to allow the communication among them. So now that we have the minimal required infrastructure up and running, I'm going to set up each one of the clusters from scratch by running some scripts that will do the following. So we have 3 regions. As you can see here, this is US West 2, so that's Oregon for the primary. You can also see it here. We have EU Central 1, that's Frankfurt in Germany, and that's gonna be for the performance clusters. And then US East 2, that is Ohio, right? And that's gonna be our disaster recovery clusters. So like I mentioned at this point, these are basically the infrastructure was deployed and Vault was started, but nothing has been configured on any of the clusters whatsoever. So if we move to this tab, right, we can see that that screen that we see right there is like, if you just run Vault, that's the first screen that you're gonna see in order to start the whole setup, right? So first, I'm going to generate some some PGP keys locally. These are going to be necessary for initializing Vault. So let's see. Let's take it's done. Okay. So now I'm going to run another one, which is basically going to dynamically pull necessary information like IP addresses of all the servers from the infrastructure that I just showed you that was deployed, in order to generate the Ansible inventory file, and so that basically Ansible knows what's where. So it's done, right? So what it did basically was it went based on this tag and gathered IPs and then other necessary information like the console tokens and whatnot. Okay, and just to clarify, these 3 windows are again the uninitialized Vault clusters, and this one will be a primary, as you can see here. This one will be a performance, and this one will be a disaster recovery. So next, I'm going to run this script, right? And this one will initialize all the clusters in high availability mode, and is also gonna configure them to auto unseal using AWS KMS. And it's going to also apply console and Vault licenses, enterprise licenses, sorry. We need this since replication, it's an enterprise only feature. So this should take 2.5 minutes to complete. And as you're gonna see here, these 3 browser screens, they're gonna change from the initial setup screen to a sign-in screen as they get configured by this script that is running as we speak. Oh, I've also made this script that is running in the background. I've also made it so that it gets all the unseal keys, recovery keys, root keys of each one of the clusters to save them locally in my machine, since we're going to need them to set up the replication portions, as well as for the validation of the replication scenarios that I'll be showing you guys. I don't need it, but Ansible needs it, right? So that's why I basically get them and save them locally. So you see the three screens already changed. At this point, we have basically the three clusters with audit log setup, the licenses, and auto unsealing. That's pretty much it. There is no data whatsoever in any of these clusters so far. So if I was, say, let me see. If I wanted to for example, log in here, in the primary cluster, right? I see you have logged in with a root token. It's basically, this is just like Vault comes out of the box. There is nothing custom on it, no policies, no nothing, right? Well, these two come by default. Yeah, these are just tools, right? So I just wanted to show you guys that I have nothing configured there for now. So for this portion, I'm going to go ahead and run this other script that will basically hydrate the primary cluster. It's gonna add data and configuration that will help us down the line for the demo. And it's gonna basically create a policy that I named God, a God policy, which basically simulates administrator capabilities of read, write, list, sudo, etc. in Vault. It's also going to enable the user pass authentication method so that I can log in using a username and password of my choice. It's going to create a user under the user pass method and call Vault admin, and it's going to attach it to the God policy. It's also going to enable the key value store secret engine, and it's going to add a super secret web app credential there. And the whole point of this is so that we can validate that it's working. So the hydration script is done. Okay. So at this point, this is sorry. At this point, let me see. Sorry, got lost here. Yeah. So this is basically what we have so far. We have the primary cluster in Oregon with the user pass authentication method enabled, Vault admin user created, and then it has the God policy attached to it. Right? So let's get to the fun portion of this webinar, the replication. So I'm going to go ahead and run a script that is going to configure performance replication. This should take around 1.5 minutes to complete. Give me 1 second. Just leave it running, come back to the screen. Okay, so as you see here, we basically want to configure Frankfurt, which was the cluster that was deployed to handle performance replication. We want to enable the actual replication, because as I showed you, they were not configured, they had nothing at this point, right? So once this script that I'm running in the background finishes, it's basically going to perform this connection here, and all the data that I had just added on the hydration step is gonna get replicated to the performance replica. All right, so so it's what this is doing is it's enabling the performance replication in the primary cluster in Oregon, and it's gonna make it the primary performance in the Oregon itself, and then it's going to jump here in this cluster in Frankfurt, and it's going to set it as a secondary performance replica for the primary, right? So basically this piece right here, that's what it's doing. Going to log in to, let's see. Okay, so it's done. Just to be clear, the init script that I ran a couple of slides ago did give me root tokens, like I said, for each one of the clusters, and I could use it to log in. I could have used it to log in the performance replica, except that, like I explained earlier, authentication tokens don't get copied over to secondary performance replicas, and this one is a secondary performance replica now that this finished. So basically, that was my main reason for enabling the user pass authentication method, along with adding the Vault admin user with the God policy, right? So that I can, instead of the token that never got replicated, be able to log in here, right? So basically, at this point, note that we don't have any disaster recovery configuration yet. It just sits there untouched. And okay, so now that the performance cluster was configured and this script is done, right? I'm going to show you two different ways to validate that the performance replication is working. Right. So one, I'm gonna run a script that is going to hit the performance replica in Frankfurt using the credentials that I just created in the hydration step. And I'm gonna extract the super secret web app secrets that I spoke about. So I'm gonna do it here. Let me see. With this script. So it's, like I said, it's connecting to this cluster behind through the API, and it's going to get the super secret credentials that I added. It not only does that, but it also like checks for the status replication and other things. Okay, so here we were able to retrieve from the performance node, basically from this one, we were able to retrieve data that was stored in the primary, right? So we can already tell that it's working, but that's not too visual. So the second way that I'm going to show you is via the UI. And so you guys can see how fast replication happens, even between US and Germany, right? And this is because since I'm using VPC peering, there is very little latency between the primary and the performance cluster. So I'm gonna go ahead and log in with the user that I created with the God policy. Right, let me log in here. Right. And then I'm going to log in the performance replica. Right, so this is the super secret web app, basically that I was talking about. As you can see, it's the same that we just pulled here. And let me show you what I wanted to show you, which was, I don't know, I'm gonna enable, let's say, a transit engine, right? Enable. If I go here to the performance replica and refresh, boom, we have the transit engine right there, right? Oh, you wanna create an encryption key? Test, create encryption key. Go here, it's already there. So it's basically a latency is null at this point. So let me see. I'm going to log off, sign out from each one of the clusters. And I'm going to go ahead to the next slide, which is now to configure Ohio as the disaster recovery replica for Oregon, right? So let's see. I'm gonna go ahead and run this script. It's gonna do it for us. So our Oregon cluster will be set up as disaster recovery primary, and the Oregon or the Ohio cluster will be set up as our disaster recovery secondary. Just like the performance setup happened, right? So the Oregon cluster would have the primary performance replication setup, and then the Frankfurt cluster, it has the performance secondary replication setup. So as you can see in the screens, as you're gonna see in any second, they're gonna change from the sign-in to Vault screen, well, especially this one, right? To disaster recovery secondary enable, right? There you go. So this script that you guys see running in the background is the one that is handling all this, right? Just give it a couple of more minutes. Not minutes, maybe 30 more seconds actually. And while this finishes, this is what the architecture basically looks like now. Sorry. Right. So this is still the primary, being primary performance and primary disaster recovery. This is secondary performance, and then this is secondary disaster recovery. Okay, it's done, right? So at this point, we have reached an optimal and desired state of replication of our Vault stack. So the primary cluster in Oregon, the performance secondary replication in Frankfurt, and the disaster recovery secondary replication in Ohio. And everything is fully working. Take my word for it. No, I'm just kidding. As you may know from experience, there is no disaster recovery plan until it has been proven to work. So let's validate that our disaster recovery plan works by running this script. That'll take around 3 minutes to complete. And what the script is gonna do, right, is going to do 3 main things, and it's basically going to take the original primary cluster out of service, out of circulation, and then is going to take the disaster recovery cluster, and is going to promote it to be the new primary cluster, just like you guys see it here in the slide, right? And it would also be, it's going to be also be talking to the performance replica in Frankfurt, right? So we're simulating basically that something happened in Oregon, they completely went offline, and so we're going to have to get back to business, and this is the first step, right? Should take one more minute. And also what it's gonna do, this same script is going to basically wait for this terminated cluster to come back up, and is going to set up the original primary cluster, right, as a secondary replica of disaster recovery. So basically, is going to flip the roles of the original desired architecture that we just had, right? So this one became the new primary, and this one became the disaster recovery secondary, and of course the primary has the performance secondary is still in Frankfurt, right? So as you can see here, now the primary became the disaster recovery secondary, right? And then this became the new primary right here. So if I go ahead and log in, right, I see everything that I was that I had basically originally in the primary, right? And if I log in the performance cluster, right? It's let me show you how replication is working by setting up what, let's enable GitHub login authentication method. So for example, GitHub, right? I'm gonna enable the method. And if I come back to the performance, and then we go here, boom, there you go, right? So that tells us that the new flow of the architecture is working as expected, right? And let me see. The last portion, of the demo, we're basically going to simulate a rollback to the desired state of the architecture, right? So we're gonna make the cluster in Oregon again the primary. We're gonna make the cluster in Ohio again the disaster recovery secondary. Right? So I'm gonna run this script, and this script is gonna take a couple of more minutes to run. I'm gonna log out. Not even logged in here. Okay. So I'm gonna basically revert back to the primary in Oregon and configure Ohio back to disaster recovery replica. And as the clusters get reconfigured, you're going to see the screens changed. It already started changing. So now again, you see the original disaster recovery back to disaster recovery secondary. It's doing some other things, like it's basically ensuring that the primary cluster in Oregon is back up, which it already did, right? It is going to generate all the necessary tokens in here in Oregon in the primary cluster to reset the disaster recovery replication. It is going to ensure that that Ohio, the Ohio cluster gets demoted from being a primary. And something worth saying as this is happening is that replication model is not designed for active usage, right? Enabling two primaries at the same time can lead to data loss if they or their secondaries ever connected. So that's why this script is taking a little bit longer, because it's basically making sure that this doesn't happen. The script also ensures that Oregon is made the primary cluster, and finally, it's going to ensure that we're fully back to this architecture that we see in the screen, including the performance setup. Oh, guys, and by the way, I'm almost done with the demo portion of the webinar. So if you guys have any questions, get ready for Q&A. That's coming right after this.
So while this is finalizing, maybe we'll ask the first question that's been dropped in Q&A, which is, if a customer doesn't have budget for Enterprise Edition, do you still recommend they utilize OSS, open source? we have a use case where the customer needs Vault, but EE is not in the budget for this year. What do you think about that question, Saul?
Absolutely, Vault is a great tool. Even for most of the cases that it covers, right? There are some other cases, like I explained, like for replication, that's not gonna be available, right? But definitely is a great tool for secret management. Yeah. And it's cloud, it's cloud agnostic, so even better.
It's more robust than any of the other solutions that we've tried.
Absolutely, absolutely. Okay, so the script is done, and we're back to our desired state, right? We're back to this state that you guys see on the screen right here. So we just basically went and simulated performance replication, validated that it worked, and simulated outage in the primary cluster of Vault, and we simulated disaster recovery basically during this demo. So I guess this is it for the replication demo. Now let's have an extra few minutes for Q&A. You guys have any questions?
We'll take just a minute here to see if there are any questions that that pop up. And Saul, you probably have already said it, but just as a quick refresher, the value of the enterprise version of Vault is it's really these features that we're, among other things, these features that we're showcasing here in this webinar. Is that right?
Yes, at least some of them, like replication. Yes. Audit log, I believe, is also a feature that is only available to enterprise. To enterprise licensed Vault. So, and like I said, for compliance purposes, it's great. There's always a way to know who did what.
Got it. Well, Saul, thank you so much for all the work you put into this. Thanks everyone for attending. If you'd like to get in touch with us, the best way to do that is to visit our website, avioconsulting.com, and use the contact form there to reach out. So thanks again for attending. Hope you guys have a fantastic rest of your day.
Okay. Guys, thank you for everything.
Bye.
Bye-bye.